My name is Boyan Onishkevich. I will be the program manager for this program. Have been at DARPA for 5 years now and currently running the AIDA and Lorelei programs, for those of you who aren't familiar with those, in case you're wondering. I will not be at DARPA for the duration of the KAIROS program. If you're not familiar with the way DARPA works, program managers come and go, and for most programs, the person who starts a program is not necessarily the person who finishes the program, with few exceptions. The agenda, we are now in a little early for the 11 o'clock session, but we will proceed because I'm sure odds are good that I will run over my allotted time. I should add that at whatever the time is that I finish, even if it's not 12 o'clock, that'll be the close of your opportunity to submit questions, either on the index cards or by email to kairos@darpa.mil. While we sequester ourselves and attempt to answer the questions, folks who want to can stay in this room and show slides or just stand up in front of the room and speak. If you're looking for teaming arrangements, that is a completely unchaperoned process. It will need to be self-organized by you folks. There will be no DARPA folks in the room. We will not be listening to that. It's just a way for you to reach out for the other folks in the room. I should also mention that this session, most of the day is being videotaped. Both that videotape and the slides that you are seeing will be posted to the DARPA webpage under the Opportunities link. The teaming session over lunch will not be videotaped. Okay, but all of the presentations, the two that you saw already and the one that I'm starting now, as well as the question and answer session, that will all be videotaped. And that will be posted to the website. That may save you scribbling notes if you so choose, and the slides will be posted as well. All right, so first some information, some of which I've already answered, or I've mentioned already. The BAA location, presumably, and Bidders Day information, at least presumably you've seen, otherwise you wouldn't be here. It says questions can be submitted until 12 o'clock, but that will be actually until I'm done with this presentation, whether it's before or after 12 o'clock, just to clarify. Both these presentations and the video will be posted. And then after today, if you want to submit, or after 12 o'clock-ish deadline, if you want to submit other questions, either on a contracting side, programmatic, or technical side, please feel free to mail those to kairos@darpa.mil. Be advised that any questions that you submit will be shared, will be posted to the website. So you may want to exclude any proprietary information about your ideas. Don't tell us, here's our technical approach. Do you think this is a good idea? Because, that sort of, all the questions that we answer, we will be posting to the website. So keep that in mind when you're constructing your questions. We don't list your name as to who asked each question, but still bear that in mind. And some of the fine print. The BAA takes precedence regardless of what I say, regardless of what the FAQ say. If there's something where we actually need to change the BAA explicitly, we will publish that as an amendment to the BAA. The FAQs really are meant to clarify things that are in the BAA that might be unclear to you, and that's just an opportunity to make sure that you're understanding the BA correctly. But the BAA is the definition of the requirement on record, so with amendments as they're provided. All right, on to the program information. So KAIROS, the overall goal of the program is to conduct some R&D to develop an AI capability using the schema model to enable us to better understand complex real-world events, both in terms of contextual reasoning and temporal reasoning, so that we can generate an actionable, structured understanding of those real-world events, what's happened to date, and to make some predictions about how they might unfold in the future. So, on the left side of this screen, it's a notional representation of what kinds of things we can find using today's technology, whether it's language, information extraction, or image, or video, event detection, from images, from video, et cetera. We are able to, in general, detect simple events, detect and classify simple events such as a meeting or a soccer game or a protest demonstration, things of that sort. Now, obviously, we haven't solved those problems, quote unquote. Our accuracy across the different media and languages and genres, et cetera, is, let's just say, imperfect. But we have been devoting a lot of energy in both DARPA programs and IARPA programs and other efforts in programs like DEFT and Aladdin and Janus and so on to advance the state of the art in that. And we are definitely intending to leverage the existing tools and state of the art in those basic event detection and classification tasks. What's missing on the left side is ways to connect those simple events into more complex events, whether causal links or temporal sequences or how multiple low-level events combine to form a complex event. So on the right, we have a representation of some of those same events, and some of those same events are put on a timeline, which is the horizontal line, with time going from left to right. And what you see is an ordering of some of those events, which is what one of the things that we're intending to accomplish in a KAIROS program. The other things that we're intending to address are relevance questions. So what's not shown in the picture, but is crucial, includes things like who are the participants in these events, the roles, the case roles, the arguments, the frame slots, whatever you want to call them. And one could imagine that there's a filter applied going from the left side of the screen to the right to really just focus on those events which involve a certain category of participants or certain individuals or certain organizations of participants participating in some capacity in those roles. Across the bottom, you see a particular sequence of 3 events that have a specific temporal sequence between them. You buy a laptop, it's delivered to you, and then you can load software on it. But the program will primarily be focusing on what's in the top half of the screen. So we see truck acquisition preceding truck modification, preceding missile launch test, and I'll be returning to that example, so don't try to parse it here because it's not sufficiently described. But what's key here is that we're linking those events to a schema. And I'll be talking at length about what I mean by schema. So that's what we see in the box up top, and the schema, and each of those events is linked to one of those, and that gives you an organizing principle for making sense of how those events fit together and what the overall complex event that is happening and what may happen next. So I'll be talking a lot more about that, obviously. So schemas. So we are leveraging a concept of schemas that emerged from cognitive science. We're specifically using the model from Piaget from the 20s. Other folks have worked in schemas, of course, as well. And the notion of schemas that we're using is as defined with these 3 bullets. Sorry, not defined, illustrated with these 3 bullets. The intuition about schemas that the cognitive scientists have come up with is that when we remember events that happened in the past, we don't remember every single detail. We generally fit what happened at a certain set of events into a model or schema of a typical pattern of things, and then we generally just remember either how this particular event diverged from the schema or particular argument roles. So for example, if I ask you to describe your grocery shopping trip from 2 weeks ago to the supermarket, you're not going to remember things like, which hand did you use to push the shopping cart, or how much you paid for bananas, or things of that sort. Odds are that you will just remember, okay, it was to, Harris Teeter was a supermarket, and you might remember something exceptional that you bought that you don't normally buy. But generally, if I asked you to tell me, when you went to the checkout counter, what did you do? You're not going to remember specifically that you unloaded your cart onto the belt and then paid for the food with your credit card and then loaded the bags into your cart. So you're not going to remember that, but you can answer that question because you have a schema in your mind for how that sort of event typically happens. So you'll be able to answer those questions using that model as a background and just filling in the blanks. So there's cognitive evidence for this, that this is how human memory works to some extent. But what's also important is that these schemas are always being adapted to any anomalous sub-events or arguments, roles that happen during a particular instance. And the third point, the third bullet here, schemas have deeper levels of organization. I'm encouraging you to pay attention to that in your technical proposals, to leverage that notion of hierarchical structuring of schemas. You don't have to, of course, but I think there is likely to be value from taking that seriously. And of course, we're not the first folks within the AI arena to attempt schemas. Going back to scripts from the Shank School, other folks have been trying to do schemas of various sorts. And here what we're describing as first wave methods. This refers to manually built structures of knowledge of the sort that early AI practiced for a long time, with the strengths of that you have sort of precise control over what your knowledge structure looks like. But The downside is that you have to manually build these things with great expense and the fragility of what if you don't remember some. I should say that there are government agencies that are building these kind of schemas or scripts or process models for their operational work, for their mission work. Generally, this is done at great expense using PhD subject matter experts. And sometimes these schemas can be, or scripts or process models can be humongous, humongous graphs, with hundreds or even thousands of vertices in these graphs. Second wave methods refers to machine learning or any of a range of training methods for learning these kind of schemas, and there's been some work in the literature about that. The big drawback, of course, of this method is that you need to have examples and then annotate those examples in order to do the machine learning, at least in the using supervised methods. And the problem is that if a government end user says, hey, can you build me a schema for how somebody, let's say, builds a nuclear bomb and sets it off, and I say, sorry, I can't do anything for you until you have at least 20 examples of somebody having done that, they're not going to be very happy, and we're not addressing our mission. So we can't rely on those kind of methods to build our schemas. So in the KAIROS model, we're proposing a general structure for a way to address learning or building these schemas. I apologize for those of you who want me to say schemata instead of schemas. I've opted to stick with schemas, although it pains me. So how do we build these schemas? In KAIROS, we're talking about a human-machine symbiotic process for building these schemas. So we're not talking about fully automated learning of these schemas, although you're welcome to propose that. But we are allowing a certain reasonable amount of either mixed initiative or active learning or any other, you name it, kind of interaction with humans who are going to be doing a certain amount of curation of what the machine learning system is proposing, adding human expertise where it's needed. So what we're suggesting is illustrated here in this example on the bottom. So what we see on the left are three of many, many examples of YouTube videos of people who took a truck and modified the truck to have some other specialized purpose beyond being a general purpose truck. So whether it's making it handicapped accessible or making it a camper van or making it self-driving or making it a food truck or whatever the case may be, we look at lots and lots of those examples, and then we use our existing image, event, and entity extraction and classification technology to build a model of the sub-events in the video of what happened. For example, getting the tools, removing a door, buying this part, that part, attaching this and that, the other thing, whatever the case may be for each of those videos. And we have some sort of moderate level of description of sub-events for each of those. And then looking at those, knowing that they're all examples of converting a truck into some other purpose, we say, can we generalize those instances into a schema for how one goes about converting a truck for other purposes? And that's the big box that you see on the right. And we see sort of the general steps there: acquisition of the truck and the parts, getting tools, removing old structure, installing new structure, et cetera, along with some ordering information. In some cases, there will be a strict order for some events. In other cases, there will not, as well as estimates of, to the best extent possible, how long each step is likely to take. Now, the level of description that you see in that big box on the right isn't very fine grain. What you're seeing there is that this notion of acquisition of truck and truck parts isn't described in detail. It just says this is, step one is acquisition of stuff. But we have a general schema that we've learned before this, or built before this, about how one acquires stuff. And generally, there's 3 or 4 ways for acquiring stuff. You can either buy it, you can find it, you can make it, or you can steal it, right? I mean, there's pretty much no other way. So we can just reuse this general notion of acquiring stuff and just call that schema to address step one. And even that schema doesn't have all the gory details. The buying or purchasing schema or alternative there, we've learned from general examples. We have lots of YouTube videos and chat and Web4 of people buying stuff, whether it's from Amazon or people buying sandwiches or people buying truck tires or whatever the case may be. There are things that are common across buying just about anything that we don't need to worry about, and we can just build a general buying or purchasing schema that we can then call as needed. So let me walk through an example in a little bit more detail. So can we, of what this might look like. It'll be the same example. So showing today's technology, at best what we can expect is these 2 discrete events with arguments for detecting events and their argument roles. So you see a truck delivery event on the right, a travel event, and a purchase event on the left. And again, we're not saying that today's technology can do this flawlessly, but this is sort of representative of what we're trying to do in programs like DEFT and some of the video and image event processing programs. But can we link these 2 subgraphs, these 2 events in some way? Can we link these people in some way? So through the magic of KAIROS produced schemas that you guys will build, the answer is yes, we will be able to do this. So what you see is those 2 graphs from the previous page linked together, where some of the arguments are merged, and there's a sequencing, temporal sequencing between those events. In this case, applied to to that specific instance. So you see time information on the graph events. Apologies for those of you who are not color sighted, but I'm going to refer to the colors in this graph. The gray stuff is what we got from the previous slide. The blue, orange, and pink stuff is what we're expecting KAIROS to be producing. So you see, or enhancing. So you see 2 person nodes from the previous page being merged together. So we knew that there was a Dr. Scott and Adam, and we're saying, oh, it's actually Dr. Adam Scott as one person participating in both of these events. We see an ordering of the events, linkings of the events. And then we're able to bring in and link in an additional event, which is the truck reuse and the modification event in the timeline. And what you see on the left is the application of the schemas that we would be using to make this happen, along with the sub-events that might be relevant. And here what we're showing is several things. First is when you show the previous graph to the human user, they could be looking at that and say, oh, I know what's going on. Or they could be saying, this is junk, throw it out. Basically, and a human curator then looks at it and can be adding additional information. They're saying, oh, okay, this truck is delivered to a missile factory, and they're modifying this truck. Odds are that what this modified truck is going to be is a missile launch platform. So they changed the label on top. They specialized this generic label, which was truck modification, to be a more specific schema, which is specialized from that more general one, which is missile launch capability development. And then from the high-level schema of the new capability development, they can see that the next step that's likely to happen in the process of developing this new kind of capability is testing of what you just built. So basically the system and the human curator are going to be predicting that we should be looking for a missile launch platform test event, in this case linked to the people involved and trucks involved, et cetera, so that you can keep your eyes open, say, maybe we already have evidence for this event, maybe not, maybe it's still forthcoming, but let's pay attention to it so that when it happens, we're able to identify that. So what this process has done is take these low-level events that are separate, link them together, identify what the complex event is that ties them together, put a label on it to tell you essentially what is the intent of the participants. And then once you have that high-level schema, you're now able to make predictions about future sub-events that haven't happened yet or that you haven't observed yet, so you can keep your eyes open for them and do whatever you need to do. That is the intended model here. You don't have to, strictly speaking, follow this particular approach. This is sort of a concept that we put into the program definition as a possible technical approach or general technical approach that could offer value. You're welcome to write your technical approach in your proposal to address the overall problem with some constraints, specifically the boundaries between the TA1, TA2, et cetera, and other constraints. But this notion of how I was showing you the generalization, specialization, and the human curation, et cetera, that's flexible for you to work with as you wish. So this is a sort of a notional model that captures what I was just describing at a more general level. So on the left, we have what's going to be TA1, which is the process of learning the generalized schemas. And what's on the right is the runtime application of those schemas to input data to produce instantiations of those schemas for particular real-world events. So on the left, you see this archived data. You have this, and again, the ordering of these boxes is up to you, but in the example I walked through, we had this generalization step, which was going from the many YouTube videos to the one schema for modifying a truck. Composition, and that's using the low-level events such as purchase as parts of the more complex event. And then specialization, this is the notion of what I showed you, taking this new capability development, and either the system or the human says, this isn't just any human capability or new capability development, this is specifically launch platform capability development, which gives you a lot more predictive value and of having this particular instance labeled. So that's what's on the left, the TA1. And I think of this as very much as a bottom-up process, working from a large collection of input sources. And once you have this library of schemas, you can now apply them to runtime data to try to do classification, detection and classification of complex events in the instance data by applying those schemas. But what you need to do with this input data is you need to do the detection and classification of the low-level events, which you then will bang against the various schemas to see which ones, see where it will stick. So what you see both on the left and on the right are, well, it's not shown here, but what is needed both on the left and on the right is the information extraction, the event extraction, detection, classification tasks. Each TA, both TA1 and TA2 will need to do those on their own, or if you have a joint proposal, you can use common technology, but I suspect you'll have different parameter settings for, let's say, your recall precision trade-off on the left versus on the right, but that's up to you to calibrate that as you wish. What's being shown also on the far right is the knowledge base. The knowledge base is where the program, regardless of your approach, will store both partially and fully instantiated schemas. So the schemas for which you're trying, that you've matched one or two items, as well as ones that you fully matched. And that's basically the working memory for trying out lots of different schemas from the input data to see which ones are going to be fully fleshed out. And at any given point in time, there will be lots of schemas partially instantiated that you don't know whether or not there will be any further information to add to those or not. All right, so this has a little bit more breakdown into the TAs. Pretty much what I described, again, the sequence of generalization, composition, et cetera, is my particular model for this. But I wanted to point out, again, a possible way of interleaving the human curation into the process. But it's up to you to figure out what makes sense for you. So what you see in the TA1, well, I'll be going through the TAs in detail, but the main point here is that what you see is the TA1 is what produces the schema library, and then TA2 makes use of that schema library to compare against the runtime data. And then the runtime user interaction is arbitrated by the TA3 performer. Okay? So TA1 in a little bit more detail. TA1 is about learning schema libraries. So this is not about doing instance identification. This is all about building a library of the general schemas, which will then be available for use at runtime. The inputs to this will be just a wide smorgasbord of multilingual, multimedia data of the varieties identified in the BAA, and the sole output of TA1 is the library of schemas. Anybody who proposes to TA1 should leverage to the greatest extent possible existing extraction, detection, classification technologies for all of the media that are mentioned in the proposal. Proposals that are only addressing video or only addressing English text or something will be non-responsive. Please make sure that your proposal is addressing the full range of media types called out in the BAA. TA1 is allowed to have its own human interaction for curation. So in the picture that I show on the bottom, I'm showing a phase of human curation where the human looks at some of the low-level schemas that the system postulates and throws out junk or clarifies them or whatever the case may be. And then the composition process to build higher level schemas, again, could be followed by a human curation process to clean that up, throw out irrelevant stuff, throw out noise, whatnot. The TA1 performers, all the TA1 work is done in advance. So it's nothing in TA1 is runtime. So this is kind of an offline process. The whole building up with the schemas is envisioned to be done once. I mean, it can be updated, but it's not meant to be an ongoing process. It's meant to be, we're building this library, we can put human resources into the curation and during this building process in order to clean up the schema library to be as clean as possible. TA1 performers are responsible for their user interface for doing the human involvement and are involved for staffing that human involvement for the purposes of the program. You will need to deliver the interfaces and the methodology so that in government use cases, the government folks can do the same using their subject matter experts. But for the purposes of the program, the TA1 performer has to do the whole process of themselves for building up the schema library offline, or not at runtime. The data provision to TA1, though, we do want everything fit into a overall architecture. So the data provision, the data feed to TA1 will be mitigated, well not mitigated, arbitrated by the TA3 system integration performer. TA2 is the runtime analysis, which takes as input one or more input documents, and I'm using document not in a text sense, but in any media sense. So input documents and the schema library from TA1. That's the input to TA2. And the goal of it is to produce partially instantiated schemas to stick into the knowledge base, which identify what the events that are described in the input, what schemas they might be part of. So in addition, so the schemas need to have things like all the, the relative ordering, who are the arguments, which arguments are shared or which roles are shared, durations to the extent possible, things of that sort. TA2 performers should also leverage to the extent possible existing technology for doing instance level detection, classification, extraction of the low level events at runtime for all the media types described in the BAA. Again, if you're not addressing all the media types, your TA2 proposal will be non-responsive. And again, TA2, the system is expected to be fit into the TA3 architecture in terms of getting access to the schema library and in terms of getting access to the input data stream. And I say stream, but the TA2 is expected to run in either batch or streaming mode. And by batch, I mean, a chunk of of many documents all available simultaneously. We haven't worked out the streaming, is it, clock tick streaming or one at a time streaming or small batch streaming or something like that. We can define that early in the program. TA3, system integrator and user interaction arbitrator, and delivery and testing in government end user spaces, beta testing the overall system, and potentially also having a role in actually running TA1 and TA2 components for evaluation purposes. So the details of the evaluation are to be determined, but one model is you submit your TA1 and TA2 boxes to, or at least the TA1 library to the TA3 and Docker containers or something to be determined of that sort. And then the TA3 folks would actually run the evaluation data. Again, details to be determined for the evaluation, but be prepared for that sort of model. So multiple roles for the TA3 performer. I talked about TA1 being, fitting within the TA3 structure. We wouldn't worry about that for evaluation purposes for TA1, as I mentioned, TA1 folks would be building their schema library offline in advance. But for the eventual delivery of the capability to government users, the TA1 capability would need to fit into the TA3 structure so that there's just one point of access to the whole prototype system for everything. The user interaction part here may end up being non-trivial because basically there will be some data structure under the hood for what the schemas look like, both the schema library and the partially instantiated schemas. Making that human palatable may be a challenge. Please think about that if you're a T3 performer. And as Mark pointed out, T3 performers need to be prepared to handle classified data. We will not be looking at classified data early on in the program, but the T3 performer may be part of conversations that we have from day one with possible government partners so that they understand what the government use cases are to help us structure the architecture in the best way. The TA3 folks also have to develop all the APIs and a Docker container and all that. I'm showing here that the TA3 is responsible for defining the schema format in a schema library and a knowledge base format. That would need to be done in consultation with the other performers, the TA1, TA2 performers. We may or may not be able to converge on a single representation for schemas that satisfies everybody, or a single representation for the knowledge base that satisfies everybody. We'll see, what people bring to the table, and how people need to, how we'll deal with that. There's not going to be necessarily something mandated, from above about how you have to represent the schema under the hood. That will be restrictive of the richness of what you want to put in there. We will, try to figure out how to make that happen. But by the end of phase one, we would need to have some sort of working model for what those libraries or repositories look like, even if we need to have two variants of what the actual representation is or something of that sort. Not ideal, but we'll work on that depending on what the technical approaches that people bring to the table. T4 are the data creation folks. For training, by that we mean TA1, training and evaluation, which means the runtime input for the TA2. This will be sort of non-trivial because what we need will be data sets where we have complex events, with different components, sub-events spread out over different media and different documents, to really make sure that we can pick up pieces of these complex events that are resident, across a variety of sources and modalities and languages, et cetera. So there will need to be some thought about doing that. The BAA talks about the number of sort of specifically identified events that we need to be sure are represented in the training data. Those will need to be, described at some high level, as described in the BAA, not necessarily detailed annotation in our sort of TAC annotation sense. It'll be a much more general and sparse annotation for that. We'll look at the TA. All of you, even if you're not proposing to TA4, I encourage you to read that portion of the BAA because that describes what the data looks like. And generally, I should say read the whole thing, not just your part. Because there's stuff lurking, all over the place that may be relevant to how you're thinking about structuring the whole program. Don't just read your bit. And then a runtime evaluation. I'm a big believer in not just focusing on English because it's too easy to cheat on semantics. If we just do one language or just do English input data sources. For the foreign languages that we will be exercising, we will be providing you with a language resource collection on the DARPA webpage under opportunities. Under KAIROS, there is a link to an example data pack for Uzbek, which illustrates what kind of data you can expect to get from the government for the arbitrary language that we will be exercising for a particular scenario. Odds are we'll end up with sort of a higher resource language than Uzbek, but not guaranteed. So basically, see what you can do with that resource collection that's in that language pack on that link. And we're not going to restrict, if you want to go out and collect your own Uzbek or whatever language resources on top of that, you're welcome to. This is not a low resource exercise. So we will have one scenario early on in the program for development, early on, as soon as possible. And then for each of the evaluation processes, we'll have a new scenario with a new set of sort of events of interest. And if the events of interest are completely new high-level events, you can expect that your sort of training data may be augmented with additional data to make sure that you have representatives of the high-level events that will be exercised in evaluation. So 9 months after kickoff, we're expecting to have a pilot evaluation, and this is really just testing out the plumbing and testing out the evaluation methodology. We don't care about your scores on that pilot evaluation as long as it's not 0, because you need to have some non-zero score to show that you actually are getting throughput and actually performing the task at some level. And then at the end of phase 1, we'll have a baseline evaluation, which really, we're saying, okay, you haven't really done a lot of new research yet. We just really sort of put all the plumbing together. You have the basic system in there. This is our point of departure. We're going to be really looking at improvement from that point. So the accuracy targets that you see in the chart, all the numbers to the right of the phase 1 column are just 40% reductions in error rate from the column to the left, so don't get too excited about those numbers. And then the phase 1 column is just speculation on our end about what today's state-of-the-art technology, if fit into this complete plumbing system, which nobody has, what we might expect, and it might be ambitious. You know, that phase 1 number, which really is the baseline number. But it's just really to show a point of departure of the 40% error reduction going to the right. Because DARPA likes to see, you know, goals for improvement at every phase. In addition to an overall evaluation, we expect to have a TA1 evaluation and a TA2 evaluation. Exactly what those look like remain to be determined. Unfortunately, NIST is home right now because of the government shutdown, so we haven't been able to work with them on refining the details, but assuming that the shutdown doesn't run into months and years, we will be working with them. If they stay shut down, we will obviously work with a different partner to make progress. In addition to the NIST evaluation, we expect to have, we'll start as soon as possible, probably phase 2 evaluations on government networks, on government data, using some sort of task completion metric that the government folks are happy with. There's a particular, I mentioned temporal sequencing, but there is a particular way in which temporal information needs to be used in order to match events against a schema. And the schemas are expected to have not just temporal sequencing of the sub-events, but to have some expectation for how long the intervals between the events might last, or how long the state of the world described in a particular event or situation is expected to be maintained, or how long each sub-event is expected to take. If you have your grocery shopping schema and you see, you know, after the first 3 steps, you see a paying event, which is 4 weeks after the unloading of your food onto the belt, you need to know that that is not likely to be associated with that schema, even though it's an event of the right type, but just the time interval makes it unlikely to be part of that event. So you need to put into your TA1 build schemas that expectation for how long each of those sub-events are expected to last, and how long the intervals are, and how long the states maintain. So in addition to events, I'm describing here states, and what I'm showing you is that there's different expectations for how long states can be valid. So date of birth, once I know your date of birth, I'm expecting it to last forever, that knowledge. I'm not expecting your date of birth to ever change. If I have information about you being married to a particular spouse as of 7 years ago, if I need to know today whether or not you're still married to that spouse, and I don't have specific information, I should be able to make a prediction based on some generalization that you get from the data or from other sources. And some, decaying likelihood of how long people stay married to their spouses. It can be just a gradual decay or, with some sort of distribution, or it can be cyclic. So if I got information about who was the president of the United States 7 years ago, I should be able to make a very high reliability prediction of whether or not that information is valid today or valid, say, 3 weeks after that first observation, but before a, whatever second Tuesday in January date has occurred every 4 years or whatever the case may be. So learning that kind of cyclicity and periodicity for the different states is important. And here's an example of information about, let's say, a certain person. I may be learning information about this person over a period of time. And basically, as an end user, if I want to know which information is valid, or basically, as an end user, I typically would answer one of two questions, or ask one of two questions against this repository of information. One is, what do I know about this person today, or about this event today? Or what do I expect to be true, 3 weeks from now or some period of time from now? And you need this information to match against the, to be able to do successful matching against the schemas. So again, this chart is kind of showing the same information that I had in the previous slide, but you see with little triangles, I won't mention the color, of where the information was first observed or second, or reinforced through an additional observation, and some information is likely to persist. Education is likely to persist. A particular job may decay. When you see new information about a different job, then maybe the previous job is over, things of that sort. All right, program schedule. Mark highlighted this in his discussion. Notice the thickness of the bars. At a program level, that's showing you how much of the program resources we're expecting to put against that TA at that period of time. For TA1, you see a thinning of the bars, which may happen then or may happen a little before that, but basically it'll be down select of, if we have multiple performers for TA1, it'll be down select to 1 or 2. TA2 is showing the same thickness throughout, but again, in any case, there may be down select based on funding needs or based on performance or redundancy. TA3 is showing a thinning of the bar, not because of any down select, because we will be awarding at most 1, well, I'm hoping 1, but definitely not more than 1 award for TA3, but we're expecting a lot of the work for TA3 to be finished by the end of phase 1. A lot of the architecture, API, definition work. Don't measure the thickness of the bars and the thinning with a micrometer that's just notional. It's not representative of the actual sort of level of effort that we're expecting to be done by TA1 versus TA2. It's just make sure you notice that we're expecting, even though there will be TA3 tasks continuing for the duration of the program, we're hoping a lot of the stuff to be done by the end of the first phase. And same thing with TA4. Again, we're expecting exactly 1 or at most 1 award for TA4. And it's just thinning at 42 months because we're expecting most of the data prep to have been done by then. but the same performer will be continuing. Whoops, the dates didn't make it on this slide, but abstracts due were January 23rd, and proposal deadline was February 27th. And as Mark pointed out, abstracts are not required, but I think it'll be useful for you to go through that process, to get some feedback on whether or not it seems like your proposed work is relevant, and so you can operate with that and refine or make choices about whether you're submitting. Some of this Mark is covered already, but I just want to highlight some of these points. Government furnished information, I already talked about the language packs that we'll provide for the language media. Lorelei language pack. Mark talked a lot about intellectual property. I won't talk about that. He talked about the security clearance. I won't talk about that. Teaming. Proposals against TA1 and TA2, TA3, TA4 are expected to cover all of the requirements for those TAs, and that includes both the media and all the other details. So feel free to make teaming arrangements as you see fit to make sure that your team covers all of the requirements for the TA that you're proposing. Teaming in principle isn't encouraged or discouraged. Put together a proposal with, staffed with whoever you need to meet all the requirements and put together a strong technical approach. Non-U.S. entities, Mark talked about that. Travel, just wanted to highlight this in the, it's in the BAA, but we're expecting PI meetings every 6 months. Generally, we've been varying the locations for those. There will be some number of them that will be in Washington, D.C. area, possibly the DARPA building, but we can expect to have meetings in other parts of the country, especially if we end up having a concentration of performers from a particular location. Or in other cases, we'll just go to a completely random town and somewhere that happens to have cheap hotels and good airfare, but no other good reason to be there. The folks who are in Aida and Lorelei, we're asking, why are we in Minneapolis or New Hampshire or what other weird places that we end up in? And the answer is no good reason other than cheap hotels and good access. And for the PI meetings, I like to hear from the folks who are actually doing the work during your presentations. So in many cases, that's not the PI, but grad students, developers, other key or non-key personnel. So very often, like in the other programs that I'm running, the PI will give kind of an overview talk, but we have specific discussion sessions with presentations from the teams about a particular TA or a particular topic. Make sure that the right people who actually got their hands dirty with that work are at the meeting, and it's good exposure for your grad students to both see what these things look like and learn how to give the talks and that sort of thing. So factor that in, please, for your PI meetings, for travel proposals, to not just one PI, but make sure that you account for, if you have more professors than grad students coming, you're probably doing it wrong. For universities, et cetera. Same thing for site visits. It's not on here. We'll be conducting site visits at least once a year. We're expecting, again, the talks to be given by the folks who actually did the work, not the PI, at the site visits. The TA3 folks should be prepared to travel to various government sites within the U.S. We're also partnering with several combatant commands who have offices outside the U.S. So for TA3, please budget for some moderate amount of travel to, let's say, a UCOM or AFRICOM type location for, maybe a couple trips per phase. Number of awards. We are expecting or hoping for multiple awards for TA1 and 2, and 0 or 1 awards for TAs 3 and 4. Nobody can be awarded both a TA1 or TA2 and a TA3 or TA4 award. You're welcome to bid to all 4, but if selected, we will pick which ones we need you for more. Because TA3, TA4 folks will have advanced access to the evaluation scenarios, evaluation data, et cetera, and we want all the TA1s and TA2s to have the same advanced warning or lack thereof. TA1 and 2 may be combined into a single proposal. TA3 and 4 may be combined into a single proposal, but no other combinations are allowed. We use CAGE code to determine what we mean by same performer. If you don't know what a CAGE code is, find out from your contracts office. But this is actually a very important point if you're expecting to bid to multiple sites. In addition to that, we may, if there's 2 teams in the same building but with different CAGE codes bidding to 1 and 4, even though the CAGE codes are different, we may look askance at that as well. Because basically we want to maintain both the reality and appearance of impartiality for the evaluation. All right, so I got done 11 minutes before my extended period of time. We'll give you another 5 minutes to finish your questions. Email them in to kairos@darpa.mil. Please make sure you spell KAIROS correctly. I already had a number of emails with KAIROS spelled incorrectly, so it doesn't get there. Sorry? Whoops. Answers will be posted to the KAIROS Proposers Day website, not to the AIDA website. Please pass your cards to Paul or mail them in. You have until 11:55 for either modality. And enjoy lunch.